Hello guys and girls, Raj here, back with another video. So a lot of you folks have been asking me to do a video on whiteboarding system design. So that's what we're gonna do in this video. So we are gonna design WhatsApp system design in the whiteboard, and not only we are going to cover the WhatsApp design, we are also going to talk about AWS services to implement the design, pros, cons, what things you should avoid, etc. So not only this is gonna help you in your normal system design interview, but this should also help you for your cloud interviews. Also, once you know how to design WhatsApp, you should be able to design the similar chat-based systems such as Snapchat, Telegram, etc. Alright, with that being said, let's get started. So rule number one of whiteboarding interview is never jump into design right away. So after the interviewer tells you the question, take a moment and then mention the features that you are going to design. Reason is WhatsApp has many features and you won't be able to cover all those features. So it's always a good idea to do some requirement gathering, like what is the interviewer looking for. And you should be prepared to mention the features. And the features you know how to design, mention them first, because generally if you mention something in the first, then interviewer is gonna say, yeah, that's fine, right? Yeah, that's good. So for WhatsApp system design, we are going to cover three big features. So the features we are going to cover today will be one-to-one messaging, send, read, receipt, the tick marks that you see, and then the last online status of a person. And also after we go through these three, you should also be able to design a group messaging feature as well. Also keep in mind that interviewer is looking for some of the design factors for you to implement in the architecture. So the system should be scalable, it should be resilient, such as it should be highly available. Even if one server goes down, WhatsApp should still be up and running, and it should be secure. Alright, so now that we have the features and the design criteria, let's start with the actual design. So at very high level, the architecture will look like this. Bob sending a message to the backend. So this is like the message. And this message could be like a JSON field sending to server. And in the JSON, it should have who should the message be sent to, right? So the send to field is set to Tina or Tina's number and then the actual message. And once the backend receives it, it sends the message to Tina because backend knows where it should send the message. And then backend will also interact with the database to either save the message in certain circumstances, save some of the information, metadata, etc. So now the question is, how should this be done? So all modern applications are done through microservices. So you will have a bunch of APIs and you will call the API appropriately. So for the Bob's WhatsApp application running on Bob's cell phone, the application needs to call an API, right? So I'm just gonna write API here. But here is something that the interviewer is looking for. API is a synchronous system. So if the Bob's WhatsApp app calls this API and this API calls this backend server some application, that application inserts something into database and then get the response back, this is a synchronous design pattern. So the problem with synchronous design pattern is all these components needs to scale together. So if there are millions of users coming and using WhatsApp, everything needs to scale at the same time. And also if something fails, if the backend server fails, Bob needs to send the message again because there is no way to retry in a synchronous design. So what you should do is convert this into a asynchronous design so that the Bob's WhatsApp application and the backend can scale independently. So how do we do this? So instead of API calling the backend server directly, the API will put the message in a message queue, and the backend will grab the messages from the queue and then carry forward. And once a backend grabs the messages and knows where to send, it is gonna send the message to Tina using an API. So here is a trick, right? Because traditional APIs, only the client calls the server, right? So Bob is a client, Tina is a client. They can invoke the backend server using the API. But how can a server call the API to send the message to Tina? So I'm going to create another section here saying like where can the interviewer probe you a little bit, right? So this is achieved by WebSocket API. This is not your regular REST APIs. So this API need to be WebSocket API. So I'm gonna write WebSocket here. So with WebSocket API, it's a bidirectional. So not only client can send a message to server, the connection stays open, and then the server can also send the message back to the client. All right, so now let's talk about how can we make this system scalable and resilient. So let's talk about this queue first. So for AWS, we want a service which can scale automatically as well as highly available and durable. So for this, we can use SQS, right? And SQS automatically scalable, scale infinite capacity, and it's also resilient because under the hood, each message will be replicated to 3 different availability zones. Also, you can have DLQ or dead letter queue in case the messages could not be delivered. Those messages could be in DLQ and can be processed by the backend. Now let's talk about the backend. So you can expect some probing here as well between the choices of the backend. So of course, we could make this a EC2, right? And EC2s, we can put it in an auto-scaling group. I'm just gonna write auto-scaling group and multi-AZ. Okay, so I kind of replicated the box to show that multiple EC2s are running. And this auto-scaling group can be configured based on the queue depth, right? Because if more messages are getting accumulated in this SQS, it can trigger and scale those EC2s and process those messages. So this is actually where you can expect some probing. So number one is the ordering of messages, right? So interviewer can say, if you are using a regular SQS, how about the order? So actually this is funny because in WhatsApp, sometimes you will notice that your messages could be out of order. It's because with this kind of architecture, it's always a possibility. If you want, you could use FIFO SQS queue. So ask with the interviewer if this is a strict requirement for the messages to be ordered all the time. Then you could transfer to FIFO SQS, but then FIFO SQS is not as scalable as standard SQS. So generally, I'm just showing one SQS, but behind the scenes, there could be multiple SQS for each region or based on certain chunk of phone numbers to make it even more scalable. So if you are using a FIFO SQS, you need even more number of SQS queues because it is not as scalable as regular SQS. So another area interviewer might probe you is this backend. So EC2 is like tried and tested. It's there for many years, right? This will work. But what if interviewer says that I don't want to pay for idle cost, right? What should I do? Like EC2, even if these EC2s are not 100% utilized, you always pay for the full cost. So you can use Lambda instead of EC2. So API putting messages SQS and Lambda scale based on the number of messages, right? So that's also a possibility. So I just put under the probe that choice of backend. For the API piece, use API gateway. So I'm just gonna put API gateway here. And API gateway can have this WebSocket API as well. API gateway integrates directly with SQS. So let's say interviewer says, hey, why API gateway? Why can't I use a load balancer? So you can, but the way load balancer works is application calls a load balancer, then that load balancer needs to invoke another program, either running in EC2 or Lambda, and that program will insert into SQS. API gateway integrates directly with SQS. You don't need a program in between. The API using AWS service integration can directly put the message into SQS, and then the backend picks it up. So that's something to keep in mind. Okay, so now let's talk about the database. For this kind of applications where the scale is massive and you need to scale up, scale down very quickly, we prefer NoSQL database, because relational database is little harder to scale because you cannot just horizontally scale relational databases. You can scale vertically, as in you can increase the size of the server that's running the database, but if you horizontally scale, add more servers, it's not that easy because you have to replicate the data and all that stuff. So Amazon DynamoDB does this quite well. So it is pretty fast, scalable, horizontally scalable, and it is pay as you go. So for that reason, I'm going to put Dynamo as the backend database. All right, so now the one-to-one messaging is done. So let's talk about sent and read receipt. You know, like when your message is sent to the server, you get 1 check mark. When it is sent to the recipient, you get 2 check mark. And then when the recipient reads it, you get like the green check mark, right? I think you got the idea. So the sent is real easy. So as soon as the API inserts the message into SQS, so this part is a synchronous call, like the Bob's application to SQS. You get a SEK back. So that is 1 check mark, right? And then when the backend is able to send the message to Tina, this WebSocket API, if this call is successful, then the backend using WebSocket API send an acknowledgement to Bob, and that's where you get 2 check mark. And when Tina opens WhatsApp in her phone and reads the message using another microservice, the WhatsApp application running on Tina's cell phone sends the acknowledgement to the backend server. So here is the acknowledgement API. Remember, microservice will have multiple APIs. So this also goes to SQS, and this is SEK queue that is sent to the backend, and there is some periodic process in the backend that's checking. So the database, it keeps track of Bob sent Tina a message, the message status is sent. And then when it is delivered to Tina, the status is updated in the DynamoDB table. that the status is delivered, now delivered to Tina's phone, and then when Tina reads it, the status changed to read, and that periodic process can send another acknowledgement to Bob using WebSocket API, and that's when you get 2 check mark with the green. Okay, so send and read receipt is done. Now let's talk about last online. So one of the design principle for massive scalable distributed application is the server should do the least amount of work, because this is the single point of failure. If you put a lot of logic in the server, as the scale increases, it becomes very difficult. So generally, what we do is we try to distribute the compute to the edge. So in this case, the edge is each cell phones. So the WhatsApp applications, when it's open in your cell phone, sends a health probe, the health check, to the server, right? Because that's much easier, because the application in your cell phone is doing the work and just calling an API, and the backend is just saving the status. So how it would work is Bob's WhatsApp application, for every 10 seconds or so, will call an API and put some health check probe message into a health check queue or health check SQS, right? And the backend will read this queue and will save it in a database table saying Bob last online is the timestamp of this health check message, right? So every 10 seconds it will go and keep on updating the table. WhatsApp will assume if the last timestamp that's in the database is within 10 seconds of the current time, that means the user is online, right? So when Tina opens her WhatsApp and go to the message between Bob and Tina, Tina's WhatsApp will do another API call and grab the last timestamp. So it do the API call, asks for Bob's last online timestamp, and DynamoDB sees if this timestamp is less than 10 seconds, then it sends to Tina, Bob is online. If it is more than 10 seconds, then it sends Tina the timestamp, and that's when you see a last online and then a timestamp. So this is how last online or last seen feature is implemented. Okay, so we talked about scalability, resiliency. Now let's talk about security. So when it comes to security, there are 2 types of security. One is security in transit. So when these messages are being sent, they should be encrypted, and security at rest. So when the messages are being stored in database, SQS, dead letter queue, etc., they should be secure as well. So for this, for security in transit, we use SSL, right? And for security at rest, we use KMS or some sort of encryption key. So both DynamoDB, EC2, so EC2 we have the EBS attached to the EC2, which is the hard disks. They could all be encrypted, and SQS, they all support KMS. So I'm just going to put KMS. And for security in transit, API gateway supports TLS. So you are covered there. All right, so we learned how to achieve one-to-one messaging, send, read, receipt, and last online. At the same time, our system is scalable, resilient, and secure. So question for you guys and girls. Using what we learned, can you design group messaging, right? Put it in the comment section, like how do you achieve it? How do you design group chat in WhatsApp. And then maybe I'll do a follow-up video to this to explain how should you do group messaging. Alright guys and girls, that's the video. If you learned something from this video, if you like this video, click that like button, smash it if that's something you are into, and subscribe. I'm trying to reach the 10,000 subscriber milestone, and any like, comment, share really helps this channel grow. Let me know if you like this video. I'm happy to do more system design, interview, whiteboarding video. Alright, with that, I'll see you guys and girls in the next video. Bye.